this was our recent code that we have tried on Proteus as well as hardware. Now what we have to do, we are going to connect this port with PA1. Okay, we have done this during our UART session. But now what I want to do, I want to display these levels on the LCD display. So for that we have to update our code a little bit. First what we are going to do, we have to do few changes in our diagram. Okay, so here what we have to do, we have to make in one on. Okay, and you have to enable the continuous mode. That these things we have to do. Okay, you have to keep in mind in rank you have to set the sampling rate as 239.5 cycles. Okay, that is the max we can get. Okay, so after this what we are having, we are having PA1 as a DC input, and our GPIO, that is for LCD display, they will remain as it is. You have to generate the code. Let's copy the code first. Okay, we'll copy this part so we can paste it later on. Okay, now let's generate the code completely. No, I don't want to save any unsaved files. Okay, so it haven't changed this part. Okay, now what we have to do, we have to do little bit arrangements for our LCD display, and we have to read the data from ADC. So let's first read the data from the ADC, which is quite simple. So first what we are going to do, we have to start the ADC. I will delete this part a little bit. Okay, now what we have to do here, we have to first start the LCD. HAL, so ADC underscore start. Okay, handler type is and HADC1. Okay, now here after this what we have to do, our ADC has been started. After this we have to do the polling. So HL underscore ADC poll for conversion, and here timeout will be HL underscore max underscore delay. This part is done. Now we have to read the value of ADC. So for that we are going to need one variable, okay, that we have to declare over here. So I'll declare it here. Let's delete this unnecessary part. Okay. Now here I'm going to declare my variable. First is u int 32 underscore t. Name is ADC value. So we have done this code previously also during the UART. Okay, this part is done. After that, we want to send the data on the display. Before that, again we need to do the conversion. Okay, we have to convert this data into proper string so we can directly print it on the LCD display. For that we are going to need a buffer. So char UART underscore buffer. So this time I am going to keep it 64 characters. Okay, we can keep 32 also because we are not going to need that much space, but as a precaution I am just providing it. So if we want to do any changes further we can do that. Okay, so this is unsigned in. We used to take unsigned in because the ADC is not going to go in the negative. Okay, now further what we have to do, we have to use that variable over here. So ADC underscore value is equal to HAL underscore ADC. So now we want to read the value and store it in our variable. So for that, get value function is there. Okay, done. Now after this, what we have to do? We have to measure the we have to what we have to do, we have to convert these values into string. Now we have value in our ADC value variable. In this variable we are going to get the ADC value. Now further what we have to do, we for displaying it on the LCD display, we have to convert it to into the string. For that we are going to need library, that is SN So for using that library we are going to install two things. That is, we are going to include two libraries. First for LCD hash include lcd.h. After this hash include stdio.h and hash include string.h. This is for the string length. So this part is done. Now what we have to do in our main code, okay. So like this we have to transmit our data. So what I'm going to do here, first let's do the conversion part. Sn print, let's see, yes, sn printf. Now here we have to provide the buffer we want to use. So we are going to use URT buffer. So by default QBID is providing the suggestions. Okay, now here first thing we have to, okay, here first thing we have to mention the size of buffer. Okay, so what I'm going to do, simply size of what, so UART buffer. This part is done. After this, what string I want to store in the buffer. So let's ADC percent LU. So that is long unsigned. This part is done. And from where we have to take the value for the conversion. So ADC value. This part is done. Now further what we have to do, we have to display these things on the LCD. For that I'm going to copy this as it is. So I'll keep some data as it is. I'm not going to change that. Okay. So here I'm going to write 00. I'll copy this as it is. After this, here what I'm going to do. So this is column, sorry, this is row and this is column. So I'm going to use row number 1. Okay, and here I have to pass the data, but data is stored in my UART buffer. So let's copy this, let's delete this part. Okay, so you don't need to use the double quotes over here, we are just having already the string inside the UART buffer. Now what we have to do, we have to introduce a significant amount of delay, because our LCD is little bit slower than the microcontroller. So here delay, and we are going to provide delay of 1000. This part is done. Let's compile it. Okay, so let's get to the Proteus. Okay, let's try to run this. Okay, so we're getting hello LCD and our ADC values. Okay, so these are just steps. Okay, these are just steps. In Proteus it can go up to your 4095, yes, but in practical life it is not going to go perfectly to the up to 4095. Okay, so this is how here you can display anything on your LCD display. Now in next part we are going to do same with the hardware, because we are having this port connected to PA1. So let's see that in the next session.